welcome to today's video. So today we're going to be looking at a very simple ISP network layout. So there are different ISPs offer different services. Some ISPs offer the triple play services, that is voice, data, and IPTV. So basically today we are looking at an overview of a simple ISP who is going to be offering a data service only. So as you're seeing that, we have AC, this stands for Autonomous System 200. So this is BGP area 200. So in the BGP area 200, we have level 1 reflectors. These level 1 reflectors are connected to the global routers. So different ISPs from different countries, traffic from different countries will be coming in from here. So when that traffic reaches the level 1 reflector, so the routes to those particular routes will be reflected to our level 2 routers, level 2 reflectors, sorry, which are clients of the level 1 reflectors. So when these ones land the routes, they will advertise them down, and this one also, when they land the routes from the level 1 reflectors, they advertise them to the clients. So and then the clients, we are able to access those particular networks from there. And also when these clients, for example, we shall configure public IP address here, just assuming, like for example, in this subnet, shall configure it here. So when this one also lands the route, it will advertise it here, come here, and keep it here on our level 1 reflector, so that in case somebody needs access, for example, access server from here, this router can advertise it to other ISPs in other areas. So these public IP addresses are assigned by one organization that controls that. So leaving alone BGP, so we have our interior gateway protocols. We have intermediate system. So here I'm using level 2, and this is the area. Can I call it the area? The area I'm using for that particular intermediate system area. So this is also OSPF here. So while we use the level 2 routers are able to exchange routes. So level 2 routers are able to exchange routes at level 2 routers. Then level 2 also can be able to exchange with the routers in level 1 and is it 1, 2. So then 1, 2 are able to exchange routes with level 1. So level 1 cannot direct exchange routes with level 2. So that's why here we have deployed level 2, so that these 4 routers can exchange routes. Then here we have OSPF. So this is our area, area 0. This is our backbone network for the OSPF network. So particularly here we have, for example, here area 1, area 2, area 3, and area 4. So we shall be seeing that in the lab. So here I've configured, maybe in the lab I've configured 3 switches due to the number of ports I have, but I've configured 3 switches, and we shall be testing these services here. And then looking at our network planning, I'm using this network of 10.2.0.0 as /24 as the loopback interfaces for these particular routers, and we shall use this loopback interface to form a interior border gateway routing protocol, this IBGP, make it a full mesh so that this route can exchange BGP routes. So then I'm using this subnet to interconnect these particular interfaces. So this 24, I've submitted it in 230. So that's giving me 2 address for this interface and this download interface. Then I'm having a level 2 cluster ID to do that's the cluster ID, and so level 1 cluster ID as that. So routers at the same level must have the same cluster ID in order to avoid routing groups in BGP. So level 1 routers have the same cluster ID, and level 2 routers have the same cluster ID. So let us go in the lab and see how things would be. So let us have a bigger picture of how everything is interconnected so that we can make good and guided decisions. Now it is good to have a bigger picture of how everything is going to look like before you make it, so that you know where you're going rather than guessing that here, or here. So this is how everything is connected. So we have our OLT. Our OLT is connected to the ODF, is the optical distribution frame. Then the optical distribution frame is connected to different optical splitters. So this is basically fiber. So those people who have already purchased maybe fiber from different companies to your home. So this is how everything is connected. That device you see in your rooms that the ISP fixes is an OLT. Or if you're using from a network tower, you may have some access point that some router that helps you to connect to a network tower of an administrator. So all this traffic goes to one device, which is called an OLT, and the OLT is connected to the network management system where your subscription are managed from. So when you don't pay the subscription, the network management system will kick you out. This is the big picture of everything. So let us go to our lab. So this is our lab. So from the OLT, we just plug the uplinks for the OLT into these core switches, and everything will be connected. Then we can add here one data center. Then we can just create here one to our clients. Probably we shall add it in the future. We shall add one data center network. So this is how everything is configured. BGP is running properly. ISI is also running properly. OSPF is also running properly. So let us, for example, do some display. Today we have used Huawei as our vendor. So yeah, I love Huawei. So let us display some BGP routing information. Display BGP routing table. So as you can see, we have our default route that is going to our external BGP. So then we have, this is the network for the server. This server is in this network. Then this is our public IP addresses that we are assigning to our clients that are configured here. Then they are advertised up to until when they reach this reflector and this reflector. So this IP table is here and also here. So if we display BGP routing, so you can see we have them there, have it here and here, and all of them have two ways we can get there. So this is how it is. So next, when we come here we have OSPF running, we have area 0, and then the intermediate system also running. So this is how we manage networks. Now it is complex at the ISP level. So, but this is just an overview. So we shall be breaking down into small pieces, but it's good to have an overview of everything when you're starting, so that you have a clear understanding of what you're doing and having good direction in achieving what you need. So we are going to display ISI routing. So we can see there are different networks. As you can see, as you saw, we have the network of 110.1.0.0.24, but have made multiple subnets to make just require two IP addresses to connect different interfaces together. So this is just a network for 110.1.0.24, but in subnets of 30. So the whole entire network of that 10.1.0.0 just is to make subnets to interconnect the devices. So then we have our service network, this for the area 2, and service area this for area 1. We shall look at that. So all of these routes are imported from OSPF. So ISI and ISI are importing and exporting routes into each other. So we are importing routes from OSPF and importing routes from ISI into OSPF. Then we are doing some route filtering to control this advertisement loop. Remember, when you just go here so that you can have a clear picture. So for example, here I'm going to import ISI into area 0 here. Then remember, when this comes and it is advertised all here, already ISI has been advertised. So we need to remove ISI so that OSPF can go up. This OSPF can go up. Remember now, here now we have OSPF and ISI, so we don't need OSPF back here. So we probably have a routing policy here to remove ISI here and have a routing policy to remove OSPF here. This is how everything is included. So if you display here, we can say display OSPF routing. So as you can see, as I informed you earlier, this is just for interconnection. Then we have our service VLAN. Our service networks are this 15.0 and 100.0. As you can see, they are inter-area. So these particular areas, for example, this area 1, area 2, and area 0, then our service networks are configured here. Then are advertised in the particular areas. For example, here, if I display IP interface brief, as you can see, I have VLAN 15, interface VLAN 15, which is our service for area 2. Then this one is used to interconnect the core switch and the router. Then I have a sub interface configured here so that we can connect to it. Display IP interface brief. As you can see, I'm using this sub interface here, namely 200. So I'm using this sub interface to connect the core router and this router client from our routing domain. So everything is connected and everything is working well currently. Then after having connected these two, we make this area 2. Then we advertise this our service network into this, and also same applies here. Just here I have a different network. interface brief. As you can see, it is here .100. So for example, if we need to ping, then here this one is having a public IP address, display IP interface brief. This is just a direct client is connected to, I forgot, add-on brief. So as you can see, we have a public IP address. So this one can communicate directly with the public server, the other side, which is 100.100.10.5. It can communicate directly, and there is nothing needed to be added. But for these ones to communicate, I added some routes on the border router there. Ping 100.100.10.5. So I added some routes there on this border router here. I have some routes added so that we can be able to communicate this to this. But here you don't need anything when you're using the public this public network here. And I wouldn't really plug in if I use this public network on a live network into a device directly, because what will happen next, you won't like it as it's not secure. So you have to pass it through a firewall. So as you can see, our network is working well. So if also I ping from here, it also works very well. So everything is well. So for example, we are going to test something. So just going to make some Wireshark here to see our traffic going through. So router 1 interface gig 0 start capture. So Wireshark should start to capture the packets. So we did some, also I did some route filtering at the BGP, because BGP was advertising some of their the interior networks of BGP into the exterior. So I did also some filtering there. So now, as you can see, there is no traffic, but if I pass traffic from here, you will see it, that there is traffic going through. As you can see, there's traffic going through if I pass it from there. So then, as an ISP, you're supposed to make sure that the system is redundant, that some of our people, they don't complain in case there is a failover of the main device here. So we have this, so I'm going to open one here. So we have this, and we have an PC4. So we have this and this. So here we are going to test a device failure. For example, if a device fails or there is a link problem, how these things switch. So this is how ISPs handle those things. So we're just having a bigger picture of everything, so that we'll be guided in knowing where we are heading to in future. So for example, okay, let me just make some good pings from this, from the devices PC1. So I'm going to make endless pings here. Ping, I'm going to make 100.100.10. Let us first do a trace route to know where the traffic is passing, so that we block that particular interface. 100.10.5. So it is passing through the 9, which is this side, right? It is passing, it's coming like this, it's coming like this, going here and going this way. It's going like this. So we are going to shut down this first, see it switch from this one. Okay, that's what we're going to do. So we are going to make, and everything is going to happen seamless. Even you, as a customer, you can't notice that there's something that just happened or a device failed, for example. So we are going to make endless pings here. Ping 100.10.5. I need like 10,000 pings. So same applies here. Ping 100.5, counting 10,000 pings. So as you can see, network is working properly, but remember traffic is going from here. So you're going to shut down one device at a time to see that everything switches seamlessly even without us noticing. So this is router 1. Just to make it small. And like the gigabyte interface are the ones connected. Then I need router 2. Router 2. So this is our router 2. Remember, these are area border routers. So traffic passes through these particular two routers. So we are going to first save before we do anything. So for example, I'm going to shut down this. I'm going to reboot interface. Sorry, Maple switch system view interface gig 001 shut down. So this is the interface going this side to the internet. So if I shut it down, you can see everything continues to work as expected. Okay. So I'm going to shut down the second interface so that internet stops when both of them shut down. Shut down interface. Also it's the same interface. Gig 00001. Hope our pings are still going. Yes, they are still going. So if I shut down this, you'll see that we shall get a timeout. So just come and click here. So as you can see now, it has timed out, right? Because now both of the links up and down. So we are going to put on this first, the one we shut down first. See that everything is working well. Shall do undo, shut down. So we shall give it some little time and go here, and here's actually, as you can see, it has already started again pinging. The traffic is moving well. So this is router 1 undo shut down. Then router 2 is still down. So if we also change this to down, undo shut down, so traffic continues to flow out normally. So sometimes most of you, even you don't notice that even that a single device went down, or even a single link. For example, this link may fail. This is gig 00. For example, gig 01 gig 00 may fail on this router interface. Gig 001 shut down. So when you do shut down, that means packets have to be switched quickly. For example, now they cannot pass through here. They have to come back this side, or they have to use this different route. So as customers, you don't normally realize that, but that's how things are working here on the core network. Basically, today we are looking at an overview of how the ISP network works. So we shall break down into small bits as we continue to learn. Maybe in the next video, we're going to be looking at the network, which is used by institutions like banks, governments to connect their branches. So most of people who do remote work, they use this. What they do, an ISP, for example, they have a firewall. This one is communicating directly to the public internet. So even you at home, you can communicate directly with this. But from here, you cannot directly communicate with this. There is some security we implement here. So we do some network translation on these border routers as the traffic is going through. And by the way, because